In this ACT video, we're going to review converting radians to degrees and degrees to radians. Now, it's important to remember that radians and degrees are just units of measure for angles. It's just two different ways to measure an angle. And oftentimes in some upper level math, we'll stick to just measuring radians. So we're going to use the fact that pi is equal to 180 degrees to convert from one to the other. That's the conversion factor we want to keep in mind. Pi is equal to 180 degrees right here. Let's highlight that. Pi equals 180. So let's start by using radians and converting those to degrees. So I'm already reminding you we're using pi is equal to 180 degrees, and all you need to do to go from radians, and I know these are radians because it has the pi symbol in it, it's not just pure integer numbers. We're just going to substitute 180 degrees for pi. So we're just going to write this as 180 over 6, use our calculator to divide that, and pi over 6 is actually just 30 degrees. So you should be able to crunch that out really quick with your calculator. Let's do a few more of these to get the hang of it. Let's look at pi over 4. So to convert pi over 4, we're going to substitute 180 for pi. 180 divided by 4, and that's going to be 45 degrees. Okay, got a couple more for you. Let's take a look at pi over 3. Again, we're just substituting 180 for pi. So 180 divided by 3 is 60 degrees. Now, those three angles probably look familiar if you watch the videos on special right triangles, and that was intentional because we're going to look at those in another video and you actually find the function values for them. So when we see pi over 4 and pi over 3 and pi over 6, it's going to get to the point where you know that it's 60 degrees or you know it's 45 degrees. So those are actually very common because we see those in our special right triangles. All right, now what about this one though? 2 pi over 3. Okay, with 2 pi over 3, we want to go ahead and substitute 180 for pi. So this is 2 times 180 over 3. Now you can do a couple of things here. I don't have my calculator on the screen, so I'm going to go ahead and actually just divide 180 divided by 3 because I know 3 goes into 3 once and 3 goes into 180 60 times. So then all I have to do is multiply 2 times 60 and I get 120 degrees. Okay. If that doesn't work for you, you can just say 2 times 180 and then divide that by 3 and you get the same value. You just have to remember when you see pi, substitute 180. Now what if we go the other way? Now we're going to convert from degrees to radians. So in order to do that, we're actually going to take our degree measure and we're going to multiply it by pi over 180. So having your calculator handy is going to speed things up. And remember, with the ACT, you are under some time constraints. But I'm going to show you some ways of doing it if you don't have your calculator handy. And sometimes working without the calculator can be faster. Let's go ahead and multiply 240 degrees times pi over 180. And when I look at 240 and 180, I just need to simplify that fraction. That's all that is some cross simplification. And I know 60 goes into both of those. 60 goes into 240 4 times, and 60 goes into 180 3 times. 4 pi over 3. So 240 degrees is the same thing as 4 pi over 3, and that's our radian measure. Okay, got a couple more for you to try. Let's take 135 degrees. Now we're converting from degrees to radians, so we're going to multiply this by pi over 180. And you can simplify the 135 over 180. You can certainly use your calculator to do that. I happen to know that 45 goes into both of them. 45 goes into 135 3 times, and 45 goes into 180 4 times. So this gives me 3 pi, 3 times pi is 3 pi, over 4. Again, you're under a time constraint on the ACT. You may not be asked to just convert from degrees to radians, but you may have to do so within a problem. We've seen in some previous videos where ACT likes to ask multiple type questions in one problem. So use your calculator to your advantage. All right, last one, converting 330 degrees to radians. We need to multiply this by pi over 180. And 330 and 180, 30 goes into both of those. 30 goes into 330 11 times, and 30 goes into 180 6 times. Multiply across, 11 times pi is 11 pi over 6. So circle that. We didn't circle this one, that may bother you. We'll circle that one too. So keep in mind that pi is equal to 180 degrees, and you're either going to substitute that or you're going to multiply by pi over 180. Those are your conversion factors.